looking at post-estimation issues. Specifically, we are looking at multicollinearity and heteroskedasticity issues in multiple regression. When we'll talk about multicollinearity, basically what we are saying is that issues of correlations that may exist between the independent variables that are used in the statistical model. And when we are talking about heteroskedasticity, we are actually basically looking at the inconsistency that may occur in the error term. But more specifically, for clarity of definition, I think I will be citing Investopedia and CFI. CFI looked at heteroskedasticity as situation where the variance of a residue is unequal over a range of measured values. When running a regression analysis, heteroskedasticity results in an unequal scattered of the residue, known as the error term. And when you're looking at multicollinearity, like I said, this is the occurrence of high intercorrelations among two or more independent variable in a multiple regression model. So, having sorted out the issue of definitions, we'll move into our Stata software. And in continuation of the study, the first edition, we will now want to test carry out two post-estimation tests. That's the multicollinearity and the heteroskedasticity test. I'll quickly rerun the do file to see where we stopped the last time. Yes, the last time we ran the descriptive statistics on the correlation matrix, normality test, and OLS regression. Now that the regression has been done, what we want to do now is, I think we'll start first with the test of multicollinearity. The command for multicollinearity is VIF. That's a variance inflation factor. Typing in the VIF, you get the result for the multicollinearity. So this is the result for the multicollinearity. The threshold for multicollinearity is that it should be less than 10. Anything greater than 10 is considered to be any model that any variable that is having over 10 is considered to have high multicollinearity issues that needed to be addressed. In this model that we ran, where Tobin skew is the dependent variable, and we have the dividend per shares, institutional ownership, firm size, ROA, and equity to debt ratio as our independent variable. We discover that we do not have the issue of multicollinearity because all the independent variable, their value are less than 2, and the threshold for IVF is 10. So on this basis, this model looks good to go with. The next thing is we need to check for the presence of heteroskedasticity in our model. This presence of heteroskedasticity. So to test, the command for heteroskedasticity is simply HE Enter. Now we have the results for the S test, and this is the Bruch-Pagan-Cook-Wisberg test for heteroskedasticity, and the assumption is normal error terms, variable fitted values of Tobins. The null hypothesis is constant variance. Now that the chi-square at 1 degree of freedom is 60, and the p-value is highly statistically significant. For us to conclude that our model does not have a heteroskedasticity issue, the p-value must not be a significance. That is, it must be greater than the 5% level. But the H test for this model shows that the p-value is far less than 5% level. So the conclusion is that our model has a heteroskedasticity issue. Now, to address the heteroskedasticity issue, we need to run the robust regression. And running a robust regression simply means adding robust to our regression command. Now I've recorded the regression command, and that's reg Tobins DPS institutional ownership, ROA, equity depth, and firm size. The next thing is put comma and type the word robust. Once that is done, enter. That gives us a new OLS regression that is robust, which takes care of the heteroskedasticity issue that was flagged by the heteroskedasticity test. Now that issue has been addressed, our model has still we're using a total number of a total observation of 160, and the fit statistics. F statistics is at 12.37, and is highly significant, which makes our model fit and proper to use. The R square for the model is 56%, which shows that the variables, the predictors used in this model is able to explain 56% of the factors that determines the value of firm as proxied by Tobin's Q. We have about 44% unexplained. So that's those are some of the interpretations. And for the significant predictors, we have the dividends per share being highly significant, institutional positive and highly significant for dividend per share. Institutional ownership is also positive and highly significant. The ROA is also positive predictor, and it is highly significant. Equity debt ratio is positive, but there's no statistical significance. The firm size is negative, and it is statistically not significant. Those are the interpretations of the robust OLS that is conducted. So this is how to address some of the issues in post-estimation issues in econometrics research for finance and accounting. I hope this helps. If you like this video, kindly like, share, and subscribe. Thank you. Watch out for the next episode.